So everyone, welcome to our coffee break today. We've got Mike Taylor, our consultant at Forgestik, that's gonna be showing us advanced SQL queries and subqueries. And if you have any questions, just go to the chat box and I'll let you start your presentation, Mike. Thanks.
Great, thank you, Tracy. Hello, everybody. Today, I want to push your skills and I want to kind of show you some examples to build better conceptual models for becoming advanced. I don't want to just show you code. So it won't necessarily just be a list of different pieces of code. I'm going to go through some of my concepts for taking your basic level queries and truly understanding where I've seen most people get stuck and giving you some information about how to get through the couple of things that I've seen prevent people go from basic to advanced. So I think it's a little bit different. So today we'll review the basics just really quickly, just so we're on the same page. I'll talk about lowering your expectations a little bit. An approach I call gather, steal, and hunt. And we'll talk about table data structures, about data sets. I think that in and of itself is one of the most common reasons why people have issues in doing more advanced techniques. I'll show you some of the other common issues that I run into. We'll talk about subqueries and derived tables, and we'll have some time for questions. So the basics, I'm just going to make the assumption in this webinar that you have at least written a few queries, you've done some stuff, you have seen the previous video that we've done. So there's a basics video more on like where the query generator is and where the query manager is and some of those things. So I'm just going to assume some of those things you're familiar with. At least select from and where, and you know that there's a HANA versus SQL difference. I'm not going to go into that. For all intents and purposes, the stuff I'm going to show you, it works all the same on both systems. I'm not here to talk details in coding. I'm here more to talk about your mental model of how you think about it in order to make you better at doing it. So lowered expectations. I just want people, like, one of the big things that when people come to me talking about trying to get advanced is they're trying to do something that's way too difficult for their level. You want to pick something that's just outside of your level of understanding that will help you to grow, not something that's going to crush you. If it's something that you want to do like a profit and loss statement as a query, that's a crazy query. You think, oh, it should be easy because I see it on the screen. And by and large, yes, you could get a list of journal entries, more like a general ledger. But to function and to do all those things as a P&L is very advanced. And I think it'll just burn out your drive to try and get your effort won't really lead to a good outcome. So set your expectations a little bit lower, especially if you're just starting, and work your way up. And people will say, I don't have time, but it really will help your approach. So the reality with SAP Business One is the majority of what you're going to be doing, especially at like an advanced level, is they're just select statements. So it's not really something that you need to program algorithms and go really crazy, but you will need to understand some of the things I'm going to explain later. So pick your poison basically just means don't pick something crazy far out of your range of skills. If you've done kind of one query, don't start by doing like a budget-based P&L query or something, which is what I see a lot of people doing and getting very frustrated. Honestly, it's worth paying a consultant who can do things 30 times faster to do those types of things than for you to try and get frustrated and do them yourselves. You eventually be able to work your way up to it, I have no doubt. It's just not useful to learn. I use this framework, gather, steal, and hunt. I joke about it kind of like being in that order. So you want to gather. It's easier to gather. Then it's easy to steal and it's difficult to hunt. So first thing, it's easier to gather things, steal, hunt. So follow it kind of this way. It's a framework for developing what you need and what you're trying to find for select statements. So if you've seen the previous video, you'll understand my process for gathering requirements. If you are saying I need some query, the first thing I try to do is trying to think like, when the user looks at the end resulting query, what columns do I need? And when I know what columns I need, I will kind of think in my head, what does this look like? And then that helps me to say, well, where is my data? So if it's something that's just business partner master data, very easy, because everything you need for master data is in OCRD, the main master data table. But if it's something a little bit more complicated, you need to know what columns you're going to need to pull from, and that will help you to use this framework. So then you begin the process, gathering. You can use simple tools, view system information. I'm not going to explain that. That's in the basic video. If you haven't seen it, go back to the basic video. View system information is by and far the easiest way to gather info. You can find the tables that way. Query generator. Remember, you can pop open the query generator, pop in a table, and you can stick OCRD in there. And if you see a bold link in there, left click, hold it, and drag it back into the list of tables, and it'll show you what table and what links. So it's really easy to gather information. I usually use the query generator to start building the query, so you can just double click and add all the columns you need. I'll format it later, and in the case of Hannah, it just won't work initially. Most of the links will be formatted incorrectly. So I'm just using the query generator to gather information as to where and what tables are going to be involved. The database reference from the SDK guide, that I pointed out in the previous video as well. You can use that as if you're really confused. It's, probably I would say I use just view system information query generator more, but the DB reference, if you need to know what specifically maybe the structure of a specific field is or what the foreign table links are, the DB reference is good if you like to use that. And then if you want just an online DB reference, maybe you don't have clear access to a partner, like you could just email Forgestik, you can email myself. We can give you the DB reference, but you can also go to saptables.net, and that has all your tables and stuff for you. Steal. So it's easier to steal than it is to hunt. So we're going to, not steal as like grand theft query or something, but I guess in a way, it's in a positive way, I would think. So, if you're trying to learn, look at examples. You might have examples already in your query manager. You might have examples that you've seen already. Use Google. There's so much information on there. You literally just Google, SAP Business One inventory queries, and it will give you a whole bunch of information in order for you to see like what tables are they affecting, how are they linking tables to other tables. It gives you a lot of overview information, and in a lot of cases you can run those queries directly on your database and see what data comes up, or take pieces of it. Take a couple columns, take one of the tables, and use that to look for what you need. You can look up functions. W3schools.com's tons of basic stuff. If you just search for like date add or anything like SQL side, they do W3 schools usually will come up. Hannah has a lot of references now, so you can just search, use Google to your full advantage. And then you'll see a developer website called Stack Overflow. If you're looking for specific examples, they'll have a lot of interesting questions on there that will give you examples of code. And then they will give you responses from other developers with a lot of context that have been voted on. So you can say, hey, here's the exact scenario I'm having. Here are 50 developers that have replied, and here are the top answers that other developers have given for that. So that'll usually naturally show up just using Google pretty much. So you want to absorb everything you can, learn, steal pieces of it, break it down, and that'll give you that steal portion. Then hunting. It's the hardest way to do things, but certain times you don't have enough data to get what you want. So sometimes it's not clear using view system information where the data is. Where am I getting information? Where is SAP getting the information? So what I'll do is I'll take some piece of table that I've got from my steal phase, and I will go select top 100 star from table. And then what you'll do is you'll see a list of that information, and you can put that right in SQL Management Studio, or you can do that directly from the query generator. Once you've done the query generator, you've executed something, you can just push that pencil in the window, just type select top 100 star from OINM. OINM is the inventory transactions table. And then what you could do is you could just scroll all the way and look at all those columns. You can see all the columns, all the pieces of data, everything relating to it. And they kind of have cryptic names sometimes, but a lot of the times you'll find kind of sort of what you're looking for. And that's where you're hunting for this particular piece of data. So you'll end up sometimes with, you'll have a couple windows open, you'll have select top 100 from. I think the most complicated understanding for SAP is kind of like maybe the batch relationships and the serial number relationships. There's a lot of weirdness in that type of stuff. So when you're searching through those tables, there's some tables that link batches and bins and all that together. A lot of the times go select top 100 from OBIN or whatever, and then the transaction tables, so I can try to start matching those pieces of the links together that I want to put together to make my structure. So you can look at that. You can go to the query generator, and you can just click in that very top left box and push tab, and it will bring you up a full list of tables. And you could just scroll down, and it has like more of a meta name where you can see the more of a human readable name. It'll say sales order addresses, sales order freight details, etc. And it'll give you those additional tables so you can hunt for them and go select top 100 star from RDR 12. And then you could be like, oh, wow, it contains all the address information. So your hunting is part of a bit more of a detailed look depending on what you need to look for. A lot of the times I'll look at system crystal reports. If you don't know crystal reports that well, I'm not going to cover it very much more in here, but if you do happen to have some familiarity with crystal reports, you can see where specific pieces are being pulled for the system information. And this is good for kind of the tax relationships, I find a lot of the time. So if you're saying, how do they relate the tax fields to a quote? Okay, well, it's different than how they relate it for an invoice. Go and dig into that crystal report, and you can find a lot of the times how the developers were thinking about the most official way of pulling data. And I've learned a lot about different things that way. And finally, the most hunt-centric tool you can possibly use is the SQL profiler. I can say I've used this only a handful of times, but the times where I've needed it have been, it's been incredibly interesting and challenging. You can just go and Google SQL profiler. I don't know if HANA has a profiler, but in the case of SQL, you can run a profiler, which will literally show you exactly what queries are being run on the database at any point in time. So you could get into a test database, filter for that test database, clear out all the results, click what you're looking for, and it will output the exact query that SAP is running in SQL. Incredibly interesting, and that's all I'll say about that. But those are your tools for hunting. So gather what you can easily gather, steal what you can easily steal, and if you're still missing something, hunt. The hardest thing for people to understand, I think both in SQL and in Crystal reports, is the structure of a table database, like a data set. So table data set structure, table data structure. When you think about building and joining and doing all the joins, that's where people get very confused. And again, here, I'm not trying to just give you a bunch of code and hey, try this, but don't understand it. I feel like you're really going to get advanced. If you really want to get advanced, you need to understand a few of these things, okay? So I'm going to show you an Excel example in a minute, but I want to talk about a couple points that I'm going to show there. So you're going to have a one-to-many and many-to-one relationship. So one-to-many could be business partners to invoices. So there's one business partner. There's only ever one business partner. You would have a many-to-one. You can have many-to-many. So you can have a whole bunch of different relationships within those tables, and you can think of each table as its own spreadsheet. So keep that in mind as we go through the next point. Cardinality versus multiplicity. I don't know if I'm using them exactly in the data science traditional exact way, but cardinality versus multiplicity is the number one thing you need to understand, and I'll show you that in the Excel example, where if you join a table that say is a one-to-many join, you are going to have many more rows than you want. So that's what I'm going to show you just in a second. And then you can use aggregate functions to combine those, and I'll jump into my Excel example here. Okay, so to understand cardinality versus multiplicity, we start with something where people start to build they'll build their query. So if you look at the query here on the right side, I just put select top 100. I'm using OINV. And again, I'm going to assume you know these tables. So this is a header of the invoice, and this is the rows of the invoice. And this is an SQL formatted, joined on doc entry equals doc entry. So what happens is they'll say, Mike, when I try to add this up, I'm getting, $688,310 for this invoice. Why? Even if I summarize it, is it giving me this information like this? Well, this is cardinality versus multiplicity. You are going to get one row for every single record, always up to the maximum number of your join. So you can see here that you have, here's an unjoined example. So you can see these are the cardinal records that you're talking about, but you can see I have not joined INV1 yet. So you're getting only exclusively that one-to-one relationship. So you have 1, 1, 1, 1, and then the total. So you'd be like, wow, that's great. 459,074.94 looks great. But when I go and I have joined the invoice rows, you're going to see these. So now you have this multiplicity effect expanding out on what you're doing. So this is such a common basic thing where people are doing crystal reports and they say, Mike, when I do this, I want to show the rows, but then I also want the document total too. So if you want to do this, you can't focus on a cardinal doc total. You have a viz order, and you can see that this has been, row 1, it's 0 base. So visual order of the rows. So now I have 7 rows times the number of the original OINV, because the data set that you're building from this query is just one big spreadsheet. Okay, it doesn't break it into separate little pieces or put them there. Your query fundamentally will be one big spreadsheet. So that's a huge part of this. So if you want to do your sum totals on here with an aggregate function, you would just sum up the line total, and given normal circumstances, the summing of the line total will give you the correct doc total. But understanding that this one-to-many cardinal table will be multiplied per row to the maximum number of rows. And this can get even worse if you try to join a tax table on here. Then you could have viz order. Say you had 2 tax codes in a jurisdiction, you could have 00112233445566. So you have to think about what you want to do in order to summarize those and how you're going to get the data out of them for getting the taxes. So I'll show a couple more examples. So unjoined, this is the cardinal information only with OINV. Remember, this has got a little bit of multiplicity effect. You would not want to use doc total to rely on, whether that's a query in a query or in a crystal report. Cardinality, this is just another example here. You're going to see one-to-many. Here's your customer codes. So you think, oh, I just want a list. I want a list of customers that have ordered from us, a list of customers that have ordered from us in the last year. And you say, why is this being repeated? Maybe you've hidden your doc number. You didn't even put your doc number row. Why is this being repeated? Well, it's a cardinality and multiplicity. You're having one invoice row per customer row. Okay, so this is why you're going to get a multiplicative effect. So the next thing I want to talk about is the aggregate effect of this. So what you would do here is then you would go and switch it to an aggregate function. So aggregates allow you to group and sum data sets into their cardinal kind of parent pieces of data. So this is where you can start using, and this again in HANA, that's very slight differences, but it's all the same concepts. T0.card code, basically you can just replace the square brackets with double quotes. So you see now we're counting the number of doc nums, and we're grouping by the card code. So you can see we're back to a cardinal amount of data, and we have a count. So that is kind of an incredible way to understand multiplicity, cardinality, and why aggregate functions are so interesting, okay? So the next piece that people get very confused by is joins. So we can see in here, C001, 001, 2, where's 2? Where did C001, 002 go? So let's jump back into our presentation. Okay, so we did table structures, those things. Another extremely common issue is joins. So the only ones that you're really going to use up to advanced, maybe once you get crazy tier, you're going to need more, but 99.9% of the time you're going to use inner or left joins, okay? So this chart down here will give you an example of kind of the information that you're going to pull. So you can see the one on the left is an inner join. It means that everything in table A has to have an equivalent in table B. And if it doesn't, it excludes it completely because of the effect of nulls. And I'll show you why. And if you use a left join, the left join will always give you everything in the left table that has things in the right table. So you can have a full list of business partners that have invoices related to them. But in scenario inner join, it will filter your, let's say A is your business partner master data table and B is your invoice table. You're not going to get all customers. You're only going to get customers that have invoices. In the left join, you're going to get all customers that have invoices. Okay, so let's drill into the data for that a little bit more. So inner join. So this is what I was kind of talking about here. So I did just a pretty plain and simple query. Select top 10,000 from card code and doc num, but it's inner joined. So we're missing some. I filtered it for date range a little bit. So where's customer 1? Where's customer 5, 6, 7, 8? Why do we have all these gaps in here? Well, the reason is you're only seeing where it has a customer and an invoice. Only customer, only an invoice. So if we went back to that chart, you only see it where it intersects. Now what we can do is a left join. So the left join adds these red results. So you can see that if you had the table from both sides, let me see if I can just paste this over to here. So now you get everything from A, and the A table would be this one, and you get anything equivalent from B, but you end up with nulls. So the left join allows you to see nulls, and this is incredible if you want to allow, say, orders that have not been delivered, or like an order status that has not been delivered to invoice, or in this case, people say, well, that's great that you gave me these ones, but where are all the customers that have not ordered during that period of time? I want to see all the active customers that have not ordered during that time. And that is what this is meant to do. So at a very high level, if you think you're missing data, try to switch everything to a left join. It's not really going to hurt you. Experiment with left and inner joins. Okay, let's jump into the next thing. So the problem now that we're leading to is nulls. So you saw the nulls there because with the business partners and the invoice example, the invoices, there just are no invoices. It's not that there's 0 invoices because null is not 0. Null is blank space. It's outer space. There's nothing there. It's not equivalent to 0. So you need to use functions like isNull in SQL or ifNull in HANA. They're exactly the same. So you would do something like my third bullet point there, isNull odln.doctotal to 0. So if it detects that you have joined a delivery and then it is actually nothing there, there isn't a delivery, it will give you the number 0 instead of null. You can also use coalesce, which is a little more advanced function, but basically the same thing. So if you use 1 plus null, it will equal null, and 1 times null, it equals null. So if you're having issues with summaries, you're having issues with your aggregate functions, you need to handle the nulls. So let's take a look at that. So I added this just as in my presentation, just as in my PowerPoint. I added a nice little is null 0 as docnum. So this replaces the nulls with zeros. And that way I can sum it up, or I can do an aggregate function to count, but still get the right information. So this was, say, doc total. You would have the doc totals, and then you would have zeros. And then it allows you to do our aggregate summary operations, whether it's doc total, whether it's whatever. So you can see it turned this null, 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 because there's nothing in B, to something more usable. So if you are getting null blank boxes and you don't want them, or you're not able to add a particular result set, maybe you're having issues with nulls. And if you look at Crystal Reports, it's the same thing. Crystal Reports has a setting to switch nulls to zeros and nulls to blanks. I don't necessarily use that. I just make sure my data set handles nulls. You can also use nulls to output like no document. So if this happens to be a number because it's a document number, but if this was some piece of information and you're trying to format something, you could change the null output to be no data, or something that you want to use to make it look a little prettier in certain cases. Okay. So those are a couple common issues I run into, being the table data structure, cardinality, multiplicity, inner and left joins, and null handling. And I'm going to talk a little bit about subqueries. So you can avoid certain problems with the multiplicity thing and the aggregate thing by using subqueries. Some people are subquery holics. They love to use them. And maybe they use them because they don't truly understand the data structure, or they don't want to use groups, or they don't want to use grouping, or they don't want to use any other method to do it, or views or whatever. It's a very slow performance, so you don't want to use it as your primary way of doing things. You're generally going to use a subquery as an aggregate or a top X number of rows. So it's be top 1. You can correlate them to outer tables, and I'll show you an example of what the subquery is. So a subquery is just a query within a query. So we're going to see here, select top 10, T0.cardcode, and then I've literally written a query within my query. So isn't that crazy? So I have the outer query, and this would be called a subquery. So what I'm doing here is I'm saying, select the sum of the doc totals, and I like to put in my subqueries as the S table aliases. So I go select sum doc number from OINV where card code equals, and then I refer to the inner query. I refer it out to the outer query, making it a correlated subquery. So for every row, it's going to run this query. That's why it's slower generally. C01000, it says how many documents are there? We're going to sum them. Boom, invoice totals. Now it's called invoice total. But you see here still that C001002 is null. What's up with that? So the reality here is you have 0 records in OINV for this. So we say, well, gosh, I can't even do a total on this. Super annoying. It's giving me blanks, but I don't understand why. So what do? We take a handling method for nulls, and we go and we say, if it is null in green, our correlated subquery in parentheses, make it to 0. So you can see I've made the subquery within the parentheses 0. So then you have a nice list, 11, 9, 15, all the way down here. And it adds it up perfectly because the nulls are no longer nulls. It says if it's nulls now it's 0. So now you can do arithmetic operations on these as proper decimals. Okay, so what would it look like for an uncorrelated subquery? This is an uncorrelated subquery. So you can see the difference. Select, blah, blah, blah. So this is, you can run these uncorrelated, but all it's going to do is literally what you're saying. So if this is something like, today's exchange rate or something that you want that doesn't correlate to anything, you can just do that as a subquery by itself, but you can see the benefit and the reason why there be a correlated subquery. And this, keep in mind, this can be where SO card code equals X and something equals something and something equals something. You can always build these to be more complex. These can be extremely complex. And when these get too complex, you might want to think about a derived table. So my final topic is a derived table. And I won't talk about this too much, but this is the next level. And I use this so much. It's so critical specifically for HANA. HANA has some issues with aggregates and in my opinion doesn't handle subqueries as nicely as SQL. So I actually have expanded I always have used derived tables, but derived tables, it basically allows you to build your own table from a query within a query. So you don't have to do a view. I'll show you that. You can denormalize the data, aggregate it, filter it, do whatever you want. Denormalize, you could take pieces out, you can change, you can, instead of using a bunch of case statements, you can modify the data so it's easier to join. And I'll just show you a quick Excel example of where you can go. So if you constantly use this same subquery, why not build it into a derived table? So the derived table is something like this, and I'm going to kind of leave this to give you something to start thinking about, but you could do your subqueries this way. So we have a pretty standard query. So if you look at this, select top 10 card code, then we'll ignore that. We'll ignore row 5 from OCRD. But what I've done is I've just made my own table here. So I've left joined. I've opened it just like I've done a subquery. I've written some random query in here, and then I've given it the table alias of X. So now the data returned here can be then correlated back to the outer query to allow me to do the aggregate operations one time in a derived query in order to put those into the main query. So you can see here I've done select, and I usually use the table alias of D0. You don't want to use your T0s inside the derived tables. I don't like to anyway. And so we'll do D0 card code. We have a summary operation. So we're doing the T0 as invoice total. So now I have a table that has 2 columns, card code and invoice total with the totals over the period of time. You could put a where clause in here too, I just didn't. Grouped by the card code, so you need that. Now I call it table X. You can call this T1 if you felt like it. I just put table X, it's more dramatic. I know that the card code exists and I'm joining it. Oh, this is actually incorrect here. I forgot to switch this. So this will be T0. So it joins it to the table here. So now you can use the columns from within your derived table, however they've been transformed. So you could do a very complicated tax calculation in here, split out GST, PST into different columns, and then link that back without worrying about your cardinality multiplicity issues. You can summarize it and do a summary operations, filter it, do all sorts of things, and then combine it back. So I would do my X invoice total, and that will correlate to this. But you'll remember that if we look back at the nulls, we would have nulls for some of those in the totals. So we need to handle the nulls. Is null. So if this is null, then you'd have that in here. This is going to output null, and then it's going to switch it to just to zeros. And that's another way of getting to the same data. And these derived tables will allow you to do so many different things for so many different situations that they are incredibly useful. So this combines a few of the different things we talked about. Make sure you left join it, do all those different things. So the left join will not restrict you only to where there are results in this query, and using your is null handles the null values in their data set. So today I have lowered your expectations, which isn't always a good thing, but in today's presentation it is, because you want to start out with something that you can do so that you really build your understanding. If your focus is only on the end goal, use a consultant. If your focus is on learning, pick something you can learn that's just outside of it and just dig into it, experiment, gather, steal, and hunt. Remember your table data structure and understand that multiplicity effect, where if you're getting too much data, look at your joins, look at those tables and either try to restrict those joins or expand those joins with left inner join, left outer join. Be aware of the common issues. We're talking about the joins and handling of nulls if you can't do arithmetic operations or you're getting blank fields. And then if you want to bypass some of those issues, think about using a subquery to kind of restrict that multiplicity effect, or using a derived table to pivot or change or denormalize, aggregate data in order to link it into the main query. So that's it for me today. If anybody has any questions, let me know.
Thanks, Mike. By the way, I just want to let everyone know, like Mike spoke earlier about prior web sessions that we did on queries, and they're all on our YouTube page. If you just type in Forgestik, and you can just type in query in the research bar, and you can see the other videos that Mike was referring to earlier. So I just wanted to mention that. So does anybody have any questions? All is good. Well, you know where to find us if you need any help. You've got the support desk, or you could just contact me, Tracy, if you need anything that I can help you with. So thank you very much, Mike.
Yeah.
See you soon, and have a great weekend, everyone.
Yeah. And comment below as well of the video. We see those and we will reply.
Yes. Okay. Thanks, guys.
Thank you. Thanks, Tracy. Bye.